All right, now, one thing I forgot to mention before as well was that often when you're working with precipitates, in order to get a precipitate, you might need to put the test tube in a centrifuge. Have you ever seen those? Have you ever used those in biology? You might use them in biology. But it's an apparatus. Normally it's got two little plastic cavities, and you put your test tubes in at an angle. You can have up to 4 of them, and then you spin it. And then as it spins, anything that's a precipitate goes to the bottom. So if, for example, we were doing a test for for sodium chloride, and it was just a bit cloudy, we weren't sure, it's simple. You put it in a centrifuge, and then if you've got a white precipitate at the bottom, there's no doubt then it's definitely going to be chloride ions present in the sample. It just helps force all the solid to the bottom. Okay? If it looks like it's taking a long time to settle.
Is that the way it's the same way gold works?
Yeah, same idea. More density can go to the bottom. Okay? All right, now, so this jumps around a bit. I don't like the order of it, but that's how the course is written, unfortunately. So, we talked last week about soaps. Does everyone remember how soaps work? Because we talked about polar solvents, non-polar solvents, and then we use soap as an example of a chemical that hides a non-polar compound in its middle. So we said that if this is a soap molecule, you remember, and as Amina said, yep, this forms a micelle, but inside of the micelle is where all of the non-polar chemicals are trapped. On the outside of the micelle, the water actually does its work, and the water, through iron dipole bonding, here it is here, all right, through iron dipole bonding, whoops, that's the negative there. Through iron dipole, it actually dissolves the micelle. Okay? And without going back through that in a lot of detail, that was what we used last week. We talked about that last week. Now, you can probably see on the board, okay, is that soap in hard water does not work. Well, you've already asked me what's hard water. Typically, normally, but not so much these days, but depending on where your source of water is, the sort of stuff that we're looking at that comes out of a tap these days from Adelaide water is pretty good. However, if you were to, say, go somewhere north and go to a dam or reservoir with untreated water, it's going to have high levels of calcium and magnesium in the water. We call that hard water. Okay? The opposite to hard water is soft water. And soft water contains potassium ions, sodium ions, and if you're looking on your solubility table, you can probably work out that sodium salts and potassium salts are all soluble. Okay? So hard water, mainly calcium and magnesium. Alex?
I think it was, we tried to stop one of my friends there in trout, but it had high levels, I think. I can't remember if it was ammonia.
Yeah, ammonia would turn into...
Yeah, and they didn't survive.
No, they would kill them off pretty quickly.
Yeah,
Yep.
ammonia, yeah.
All right, now, so hard water contains calcium and magnesium. So when we actually dissolve soap into water, it has to be soluble. Everyone agree? So this is soap. Soap is a solid, and it's a very complex formula. When I dissolve it into water, we simply do the same thing as what we did over here with a simple ion. It's just a big ion, that's all it is. So it does this. So it forms our carbon chain, and that is the negative, and we know that's a Q. That's the soap ion that does all the work. And of course the other thing will be the sodium ion, and the sodium ion doesn't do anything in the solution. We're going to make soap tomorrow, by the way, and detergent, all right? So this is what does the work. That's the soap molecule, and here it is forming a micelle. The issue is this though, in hard water. If I've got lots and lots of these ions, so if that's my soap molecule, if that comes into contact with either calcium or magnesium, So let's assume I'm throwing soap into hard water. We end up with a bit of a problem. Long carbon chain, there it is there, O minus. And the problem is that as soon as I have calcium ions down here, and I just need to put a bracket around that, it's a very complex ion too. If I have calcium ions, we have a problem. Because as soon as I use soap in hard water, it becomes a precipitate. That's the formula for the precipitate. It's not complex. It's just a double ion, because soap's only got one negative charge, to balance it out. Alright, it's just like calcium chloride, CaCl2, but I've got the soap molecule first, negative ion first. And this is called soap scum. And you would probably sort of be aware of that anyway, because if you've actually ever used soap to wash your hair, does anyone ever, I haven't got that issue anymore, but if you ever use soap to wash your hair, okay, a gum nose, he wouldn't even go near soap, alright? No, because you'd use shampoo or something else, yeah. Okay, now, so if you've ever been camping, for example, and you're desperate to wash your hair, and you only had normal soap, just body soap, and you wash your hair, what does it do? What does your hair do? You wash it with soap, what does it do? It goes really hard, because it normally sticks up everywhere. Because what's actually happened is, you've actually deposited all the soap scum in your hair. It's actually, it's on your actual hair. It's attached to the hair. Yeah, on your scalp. And so, it goes all sticky and gluggy, because you couldn't dissolve the soap molecule. It's formed a precipitate on your hair. Okay? And you can't get rid of it. The only way you can get rid of it is to use detergent, i.e. shampoo. Shampoo will dissolve the soap scum that will be on your hair. The same thing if you do any washing. Does anyone washing your clothes? Yeah. Yep. So you know that if you just use normal soap, as in body soap, to wash clothes, they go like sticky. And the reason why they go all sticky and they don't dry properly is because all that soap scum is trapped to all the fibres. You can't get rid of it. Okay? That's why you've got to use laundry soap. Laundry soap which has got a detergent in it, because detergents don't form a precipitate in hard water. That's the difference between the two. So soap, look, for everyday use, not a problem. You know, getting your hands clean, that sort of stuff, and getting the oils off your body, not a problem. But if you're going to use soap in hard water, don't even bother, okay? You're going to make more work for yourself. So, what do? Well, two options. We can either use soft water, change your water supply, which is sometimes not that easy to do. So if you're using rainwater, okay, or in this case here, Adelaide water. Adelaide water, we did a test on it 12 months ago. Adelaide water is really low. It's low in calcium magnesium. It's quite amazing how good Adelaide water is. We actually use Adelaide water now for our distilled water. How you going, George? So we use that for our distilled water now. I'm just recording, so I'll keep on going. Just don't mind me. So what we find is this. If we use soap in hard water, not very successful. So we've obviously developed detergents. Detergents, notice they've got a different polarity, okay? And a different polarity means if I add this to water, and I'll do that equation, AQ, and I'll finish it off, okay, that will dissolve, and it's going to give me this compound here. Whoops, that's a sulfur, sorry. O minus. So here's my detergent molecule going to work, and my sodium ion is soluble. Now, if I take that and add calcium ion, it will form a calcium salt. However, the calcium salt of this compound here, which is a sulfonate detergent, O minus, Ca plus 2, bracket, bracket, AQ. It's soluble. Again. Good. I'm just recording a lesson for the boys. Alright. So what do we do? So the moral of the story is don't use soap in hard water, otherwise you're going to get all sticky stuff in your hair and in the sink and on your clothes. Okay? That's what we use detergents now. So detergents were developed in the 50s because they've got a specific role. What's your name? What's your name again?
This is Ted.
What is it? Sorry?
Ted.
Ted. Hi Ted. I remember your face from a few years ago. Alright, so detergents in hard water really work well. Soap in hard water, don't even bother. Okay? And so that required understanding of precipitation reactions. Everyone happy with that? So that was what we were trying to get out of those two discussions. Alright.